Now we're going to hear from Justin Stout. He is a geospatial research scientist at University of Canterbury.
Thanks all. So obviously I'm presenting for James today. So basically we went up at the end of February to map the distribution of the impacts of Cyclone Gabrielle with using LiDAR based on a helicopter. The goal was to kind of quantify the extent and amount of sediment that had been deposited or eroded due to the cyclone. The results of this has shown, as we've heard, many landslides, lots of sediment moving around, being deposited up to 6 meters in places within the floodplains, and it's being used to support these flood simulation hazard models, and to start to develop some catchment scale sediment budgets, looking at where the sediment's coming from and where it's going. And so over the 5 weeks from February, we captured roughly about 1,700 square kilometers of quite dense 50 points per square meter LiDAR, and we're in the process now of comparing that against the 2020 PGF LiDAR. And so some of the outcomes we've had so far is we've been able to produce these elevation change maps at a 1 square meter resolution and provide it to the regional councils and ministries to start to identify where at in the floodplain has there been a lot of sediment deposited, where's massive, big mass wasting events or big bank failures occurred. Building on that, we've then been able to supply some more localized information to the NIWA, focusing on the areas that they're interested in. And then we've also supplied data to Gabrielle and the councils looking at where there were massive levee failures or where the railroad failed or got washed out. And so kind of where we're at now, where we're sitting is the data that we're delivering is a classified point cloud, essentially just off ground colorized, as well as a DEM and a DSM for each of the areas. This says 60%, but I think we're probably closer to 80% now. And the idea is to start to host this on Lens for other people to use, and take advantage of this high resolution data. And so then using this time series that we have now compared against the 2020 LiDAR, we're able to start to develop these 4-dimensional maps in terms of looking at where failures occurred, where sediment might be being stored within the catchment that's going to move through the landscape as a wave in the future. But we still need to start to develop uncertainty maps around, so basically looking at the biases within our LiDAR that we captured and the 2020 LiDAR to start to look for uncertainties so that we can give true, true's not the right word, but give some sort of uncertainty around the numbers that we're reporting on. And I think based on where we're sitting now, I think we're looking probably closer to November to deliver these, to deliver the change maps. And as Belinda said, I'm actually just returning from recapturing the whole of the Esk, Tangio, and Arapaho catchments, with the goal of using this LiDAR to start to understand these broad catchment scale delivery mechanisms and understanding, how much came out of the hill slopes, how much is being stored in the river, and how much was delivered out to the ocean. And I think we're on track probably to deliver that by the end of December, or at least start of next year. And then once the rivers clear up and turbidity goes down, we'll go back up and use our bathymetric LiDAR unit to resurvey the rivers, particularly through the Heritonga Plains, with the goal of looking at what happened to the bed levels. Did they rapidly degrade, or is there massive points of incision, and understanding that. Thank you.